Namaste and welcome back to the DSA classes. Today we are going to be solving another program which is to find the power of x raised to the power y. Very simple. What does this mean? Assume x is 5, y is 8, which means they are asking you to find 5 to the power 8. And you know 5 to the power 8 is this. How we are able to think. So how are we going to write a program for this? Now there are multiple approaches you can use. A recursive way of solving this is quite famous. Whether it is efficient or inefficient, later we will explore. But recursively, how can we solve this? Very simple. See guys, what I am trying to say is, assume I want to find 5 to the power 8. Now you know 5 to the power 8 if I want to calculate, can I say it is equal to 5 to the power 7 into 5? Would you agree with me? Would you say if I want to find 5 to the power 7, it is 5 to the power 6 into 5? 5 to the power 6 is 5 to the power 5 into 5. Similarly, 5 to the power 5 is 5 to the power 4 into 5. 5 to the power 4 is 5 to the power 3 into 5. 5 to the power 3 is nothing but 5 to the power 2 into 5. 5 to the power 2 is nothing but 5 to the power 1 into 5. And finally, 5 to the power 1 is nothing but 5 to the power 0 into 5. And 5 to the power 0 is nothing but 1. So would you agree that here the chain ends? And that way you can keep substituting and you can find the final result. So would you agree? That is nothing but my base condition. When the power or y value becomes 0, then I should return 1. But all this, don't you think I can write it as a recurrence relationship which looks something like this? X to the power y is equal to x to the power y minus 1 into x. Would you agree? It satisfies all this. So this is the recurrence relationship. Simple. Now that you know this, would you agree we can directly go write some code? How to write it? Let me show you. So I've basically created a function which called as power, which accepts x and y, x being the base, y being the power. Now if you see, I've made the return type as long, not integer. Because sometimes the power is so huge, right, that it may not essentially fit within an integer which can only store 32 bits, right? So I'm not taking a risk and I'm creating a variable which is long, right? Great. Inside this, directly I will just write return and that recurrence relationship that we just calculated, which is to calculate the power of x raised to the power y. I'll again call pow x and comma y is going to become y minus 1, y minus 1, okay, into x. And don't you think this is the same as that form that I showed you? X to the power y is equal to x to the power y minus 1 into x. Simple. Any confusion till this point of time? Will this work is the bigger question. But before that, base condition is very important in recursion. Otherwise, this will infinitely keep calling itself. So just go and tell if in case. What is the base condition? When power becomes 0, you know result is 1. So if in case y becomes 0, because every time you're telling y minus 1, y minus 1, y minus 1, if it becomes 0, then I will return 1. Cool. Now if in case I go and just execute this, then clearly one can notice you will get 3,90,625. So it works as per our expectation. But this, my dear friends, is extremely inefficient because let us assume I wanted to find 5 to the power 1000. Then for 1000, I need 999, 998, 7, 6, 5, like that 1000 times I'll have to keep calling this function. It is in a way you can say big O of n complexity because whatever is the power that many times it has to execute, right? So it is really not efficient. So first of all, recursion is not very efficient in terms of memory because I've showed you the kind of events which occur in the stack and how the stack gets filled with stack frames. Now, on top of that, if it is inefficiently written like this, then it's a nightmare, right? So, if I were to pass some very big power, y value, you would see the output itself would take some time to come. So, is there a way to make it more efficient? Yes, there is. How to do it? Let me show you. Now, let's think of a more efficient approach, guys, right? Now, think along with me. We have 5 to the power 8. If you look at the power is even. 8 is even. If it is even, then I can express it as 5 to the power 4 into 5 to the power 4. I can do that. Correct? Simple mathematics, basic mathematics. Now, if I have to represent this as a recurrence relationship, then I can say x to the power y is equal to x to the power y divided by 2 because it's becoming half into x to the power y divided by 2. Now what is the advantage of doing this, you may ask? If you look at it, if you look at the previous approach, your power was just reducing step by step, right? From 8, 7, 6, 5, 4. But now the power is getting halved every time. It's reducing by half. Obviously, don't you think the number of calls you will make will drastically reduce, my friends, right? Beautiful. But this is for even. See, I'm putting a box and showing you even. But if in case it was odd power, 5 to the power 7, then I can't represent it as y by 2. It's not, mathematically it's not possible. So if it is odd, I don't have any other chance or any other opportunity to represent it the way I did it in even. So I will stick to what we were doing previously. If power is odd, 5 to the power 7 is nothing but 5 to the power 6 into 5. If I have to represent it in a generic form, it is x to the power y is equal to x to the power y minus 1 into x. Would you agree? I am putting a box showing you odd. What I am trying to say is that for even, this is the recurrence relation. For odd, this is the recurrence relationship. So, would you agree? In your program, if you can do a simple thing, where you first check what is the value of y, is it even or odd? If it is even, then call the function in this way. If it is odd, call the function in this way. 100%, at least for even numbers or even powers, your efficiency will increase. I hope you're able to think. Shall we quickly go implement it? Let's do it. Now let's write some code, okay? In the code, if you observe, for whatever is the power, which is y value, I'm not checking whether it's even or odd. Directly, I'm always using this. But we saw there is a more efficient way to do it if the power was even. So what I will do is, I'll just go here, press enter, and I'll put a condition if in case, right? If y mod 2 is equal to 0, it means it is even. If it is even, I will go inside it and I will tell return. And see, I will use that even recurrence relationship. So that is nothing but power of, okay, base is x only, but the power y will become y by 2 into same thing, power of x comma y by 2. That is what the even recurrence relationship is saying. Any confusion till here? Great. Else, I will come here and I am going to put this there. I hope everybody understood. If it is not even, it's odd. If it's odd, same recurrence relationship. Will this work? Right? Let's see. So, as you can see, y is 8. 5 to the power 8 only I am finding out. If in case I execute it, certainly we have got the same answer. So, definitely it works. There is no problem in terms of the working. However, this approach is still not extremely efficient. You can make it a little bit more efficient. How, if you wonder? For that I must show you what the recursion tree looks like. Let's go have a look. Now let's form the recursion tree, okay? 5 to the power 8 I have. Obviously power is even. If it is even, I will use that even recurrence relationship and hence I will get 5 to the power 4, 5 to the power 4. Would you agree? Same thing. Again 4 is even, so again 2 calls. 5 to the power 2, 5 to the power 2. 2 is even, again 2 calls. 5 to the power 1, 5 to the power 1. Now this is odd. Because it is odd, I will do y minus 1. So I will get 5 to the power 0. 5 to the power 0 is my base, so I will return 1, right? Whatever I will return, I will multiply that with the number itself, which is x. So x here is 5, base is 5, so 1 into 5 is 5. Come this side. This side also same thing, 5 to the power 1 I will get. 5 to the power 1 is odd, so 5 to the power 0, it will return 1, 1 into 5 is 5, 5 into 5 is 25, that is what it will return. Now come this side. Now look at this side, guys. If you look at this side, it is 5 to the power 2. What I will get below 5 to the power 2 is the same as this, nothing new, same as this only. So that's what I am also showing. Same thing you will get. This will also return 25. But same thing only it is doing, but you are calculating it again. Once more you are calculating. Similarly, 25 into 25, you got 625, great. Now, again here 5 to the power 4. Would you agree? 5 to the power 4, if I start calculating, it will look same as this. That's what I am also showing. See? Same. This will also return 625. 625 into 625 only is your answer. Hope everything. But if you look here, left hand side, right hand side, same. One more thing, observation. 5 to the power 8, 8 is there in the power. Look at the base conditions. How many times have you hit base condition? 1, 2, 3, 4, 5, 6, 7, 8. Look at this 5 to the power 1s, 8 times. If I had 5 to the power 1000, I would have calculated the base condition 1000 times. How did it become more efficient? I am asking. 1000 times. This would have also got calculated 1000 times. But that 1000 times can be made 500 times straight. You can reduce it by half because you are just doing the duplicate operation. You are again finding the same value. See, same, 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 same. Why do you want to do? 1/2 you can eliminate completely. So, would you agree that whatever I calculate here, if I can store it inside a variable and make that value multiply with itself, make that value multiply with itself, I'll get this side, because this side also is returning the same value. Once I get 625, if I store 625 somewhere and multiply it with 625 again or square it, I'll get the same thing. I hope you're able to think. So this side can be eliminated, which means, would you agree, efficiently speaking, if I were to store it somewhere and multiply, this entire side, my friends, this entire side can be eliminated. Even here, 5 to the power 4, 5 to the power 2, 5 to the power 2, this entire side can be eliminated. Even here, 5 to the power 2, I found out this side. Why do I need this side? Because whatever value I get here, I will multiply it with itself, which means this entire side can be deleted. Look at the number of calls which has disappeared. So I hope you understood where you have made a mistake. Let's go correct it. Just one change. I'll go here, I'll press enter after this. Now what I will do is I'll cut this power off. That entire line you can just cut it off. Yeah, right. Remove that. On top, I'll just paste it. Remove one power off call. I'll remove it. So whatever this gives me, I'll store it within a variable. Whatever this returns, I'll store it within a variable. Let's call it as res. Int res. Or long res, correct. Next I will come down and here return. Return what? Result into result. That's it. Simple, guys. I hope everybody has been able to understand. If we do this, internally computer will thank you, but output will remain the same. If I execute it and I go, you can see same thing. Any confusion? So I hope if anybody now asks you how to find how to write a recursive program which can find the power of a base and a given power, easily you will be able to write, and you will also be able to justify the way you have written it. Okay. So I hope you enjoyed today's class. Keep coding and I will catch you in the next class. Take care. Bye-bye.